So today we're going to talk about normal distribution. Normal distribution is going to carry through this entire course. It's one thing that's used to do quite a bit of statistical analysis. So as we discussed in week 1, just briefly, normal distribution is where you have data that fits on this bell curve where your mean, median, and mode are all the same number. They're all right there in the middle. And you have symmetry on either side where 50% of your data is on either side, and it's gradually getting less and less as you move away from the mean. So there's some key terms with normal distribution that you'll want to know. The first one is a standard normal distribution. And a standard normal distribution is where the mean, represented with this little symbol called mu, is 0. And your standard deviation, represented with this little sigma, which almost kind of looks like a fancy R or a circle with a little tail on it, is 1. So this is the standard normal distribution. And what we'll end up doing is any set of data that we have that is a normal distribution, we will convert those so that they are in the form of the standard normal distribution. So we'll convert them so that their mean is converted to 0 and their standard deviation is converted to a 1. Okay? So your basic bell curve looks like this, where your mean is 0, your standard normal distribution, the mean is 0, and 1 standard deviation away from the mean is kind of right where it starts to almost curve out. So you have this sort of curving in, and then it starts to tail out. That's where 1 minus 1 standard deviation and plus 1 standard deviation from the mean are. Your second standard deviation on both sides is where it really you have just a little bit of a tail left here, because within these two standard deviations is 95% of your data. And you'll notice here with this 4 standard deviations, it's practically done. There's almost nothing that would be 4 standard deviations away from the mean. 3 standard deviations, if you look right here, is almost the entire thing. It's 99.7% of the data. So by the time you hit about 3 standard deviations away, most of your bell curve is done. So as I referred to, we take our data and we're going to convert it to this standard normal distribution. How we're going to do that is in order to figure out it's called a z-score. A z-score of a certain data, you're going to take that score, that piece of data, subtract the mean, and then divide it by the standard deviation. And what that's going to give you when you do that, again, take your number, subtract the mean, then divide it by the standard deviation, that's going to give you how many standard deviations away from the mean that particular score is. And again, when you get to the example video for this week, I will do examples of converting to a z-score. So just a couple notes before we end up, before you're on the example video. In order to solve for a percentage, so if you have a z-score and you're trying to figure out what percentage, what your score's kind of value is, what percentage is below or above that score, or what the percentile is, the one thing I want to make sure you always do is you want to make a sketch of these problems. When you're working with normal distribution, draw the picture. So there are something called central intervals when it comes to normal distribution, and this is really those cutoffs of 1, 2, 3 standard deviations away from the mean. And they have kind of overall percentages. So if you know for sure you're exactly 1 standard deviation or 2 standard deviations or 3 standard deviations around the mean, then you'll be able to calculate without having to use your calculator or any kind of table the percentage. So in this picture here, you can see that between the mean and 1 standard deviation below is 34% of the data. Between the mean and 1 standard deviation above is 34% of the data. So within 1 standard deviation above or below the mean, which is often referred to as within 1 standard deviation of the mean, is 68% of your data, 34% plus 34%. Then if you go to 2 standard deviations, between 1 and 2 standard deviations is 13.5%. Between 1 and 2 standard deviations is 13.5%. So if you wanted to figure out within 2 standard deviations of the mean, you would add these 4 numbers up. 13.5% plus 34 plus 34 plus 13.5, which gives you 95% of the data. So 95% of the data is within 2 standard deviations of the mean. But if you were looking at between the mean and -2 standard deviations, you could add these 2 numbers up just to get that part only. Then between 2 standard deviations and 3 standard deviations is 2.35% on both sides. So that then takes up 99.7% of the data. You have this little bit, 0.5% here, 0.15% here, and 0.15% here, that make up the rest of the tail. That would be 3 standard deviations or more above the mean, 3 standard deviations or more below the mean.